We don't usually think of dinosaurs and aliens in the same sentence, but what if I told you that an alien civilization living 65 million light-years away could, in theory, see dinosaurs? Yes, actual dinosaurs. This fascinating question comes from Dr. Matt Kaplan, a physicist who explored light, space, black holes, and telescopes, all to answer one intriguing idea. And today, we're going to explore that journey. So, could aliens see dinosaurs? Theoretically, yes. Here's how it works. Light takes time to travel. That means when we look at something far away, we're actually seeing it as it was in the past. The farther away it is, the further back in time we are looking. If your eyes are about 60 centimeters from the screen, you're seeing this video just a few nanoseconds after it was generated. That's practically instant, far faster than your brain can process, so you don't notice it. Light from the moon takes about 1 second to reach us. Light from the sun takes around 8 minutes. If the sun disappeared right now, we wouldn't know for 8 full minutes. Now extend that to much greater distances. The light from distant stars can take thousands or even millions of years to reach Earth. That's why a light year is not just a measurement of distance, but of time. It's how far light travels in 1 year. So the light that left Earth 65 million years ago is now 65 million light years away, carrying an image of Earth during the time of the dinosaurs. That means, in theory, if aliens were living in the right place and had the right telescope, they could be seeing Earth during the age of the dinosaurs. But let's be realistic. They would need to know exactly where to point their telescope. Earth is a tiny target from that distance, and 65 million light-years is enormous. Most stars we see at night are within 1,000 light-years. The Milky Way is about 100,000 light-years across. The Andromeda galaxy is about 2.5 million light-years away. But to see dinosaurs, aliens would need to be in the Virgo cluster, over 65 million light-years from Earth. And that brings us to the real challenge, the telescope. To understand what kind of telescope would be needed, let's think about how seeing works. Imagine the sun is constantly shooting out trillions of tiny particles in every direction. These are photons, the particles of light. Some of them bounce off a Tyrannosaurus Rex. A few of those photons travel through space. If they reach your eye, your brain receives that signal and registers the image of a T-Rex. The farther away you are, the fewer photons reach you, making it harder to see. Telescopes solve this problem by collecting a lot of those photons with mirrors and lenses, then focusing them into a single point, like a giant artificial eye. The farther away the object, the bigger that eye needs to be. So how big would a telescope need to be to see a dinosaur from 65 million light-years away? To detect Earth as a single pixel from that distance, the lens would need to be over 57 million kilometers wide. That's about 1/3 the distance from Earth to the Sun. The telescope would span nearly half the orbit of Mercury. But they wouldn't just want to see Earth. They'd want to see a dinosaur. Even to spot a dinosaur as a single point, the telescope would need a lens 4.4 light-years wide. That's larger than the distance from our Sun to Alpha Centauri, our closest star system. Human astronomers have fun naming telescopes things like the Very Large Array or the Extremely Large Telescope. But in this case, even the most absurd names wouldn't be enough. And now the final problem. We don't even need to wonder whether such a telescope could be built. Physics already has the answer. According to Einstein's theory of general relativity, matter curves space-time.
The more mass you concentrate, the greater the curvature. If you concentrate enough mass in a small space, it collapses into a black hole. A lens with a diameter of just 28 light minutes would already have so much mass that it would collapse under its own gravity, forming a black hole. So, yes, in theory, the light carrying an image of a dinosaur is still out there, traveling through the universe, but in practice, no alien will ever see it. This script was written by Dr. Matt Kaplan and adapted from an article on his website, quarksandcoffee.com. Thank you for listening. If you enjoyed this, don't forget to like, share, and subscribe for more content like this. Until next time.